In this video, we're going to talk about function notation. And you're probably used to seeing equations written as y equals maybe x squared plus x, y equals 8x minus 5, things of this nature. The idea is, maybe you have a couple of equations that you have to deal with in the same problem. I always thought of function notation as maybe just somehow being like a name. So what we're going to do, instead of using y, we're going to replace it with f. So it says f of x equals x squared plus x. So I always just kind of thought about f as being the name. And it's not f times x, it's read f of x. So make the careful distinction. This is not multiplication at all. It's just one of those cases of, I think the notation maybe could be a bit better, but this is kind of what we're stuck with, and this is what we use. Whatever the variable is, that's what's going to go inside of here. Likewise, maybe I can name this other function down here. I can call that g of x equals 8x minus 5. That way you can kind of make a distinction between the two equations. If I'm talking about f, I'm talking about this one. If I'm talking about g, I'm talking about the second one. From there, you can just talk about evaluating a function. So suppose I use these two equations that I have here. If somebody said find, say, f of 4, well, all I do is I find my f equation, and everywhere there's an x, I just plug in simply the number 4, and then I simplify it down. So 4 squared is 16. 16 plus 4 is 20. So you could say that f of 4 equals 20. Likewise, if they said calculate g of 4, well, g of 4, again, I just find my g equation, and everywhere there's an x, I replace it with the number 4, and then I just simplify it down. So 8 times 4 is 32. 32 minus 5 is 27. Likewise, you can replace, instead of just plugging numbers in, you can certainly plug in more complicated expressions. So suppose I want to evaluate f of, let's make it x minus 3. Well, again, what I'm doing is, it says before I just had an x in there. So it says whatever's here, that's what I'm squaring, and then I'm adding the same thing on. Well, now if I plug in x minus 3, instead of just plugging in x and x, I'll replace these x's with x minus 3's. So in that case, I'll get x minus 3 squared plus x minus 3. And now I could again simplify this out. Recall that x minus 3, this is x minus 3 squared, so we have to multiply it. Don't, just say it's like x squared plus 9, because that's not correct. You're going to have to FOIL everything out. I've got my other x minus 3 hanging out. Since there's a plus 1 hanging out front, if I distribute, I'm just going to get the same thing back. So again, if I multiply x times x, I'll get x squared. If I do on the outside, I'll get a minus 3x. On the inside, I'll get another minus 3x. Negative 3 times negative 3 is positive 9. I still have my original x minus 3 hanging out. And if I combine my like terms, I'll get x squared. I've got a minus 3x, that's minus 6x. Plus another x, so minus 6 plus 1 is minus 5x. Then I have positive 9 minus 3, that'll leave me with positive 6. And this is now equivalent to the expression f of x minus 3. So this is the basic idea with function notation. Instead of y, they're replacing it. Usually, most books, if you just have one function, they'll just label it as f of x. But again, the idea is you're just plugging a number in, you're just replacing x with whatever particular value you happen to be substituting in. So definitely feel free to take a look at the other videos. We're going to talk about adding and subtracting functions, as well as multiplying and dividing functions, and also about compositions of functions. You can find all of those videos on my website, justmathtutoring.com. Go to the free video lessons tab on the left. There should be a link on this video on the right hand side that'll take you there. At the top there'll be calculus topics, and further down you can find algebra topics, where you can find videos dealing with function notation.